Good evening to one and all. This is Shishkaladhar, physics teacher. Today I am going to demonstrate an activity to understand about diverging lenses. The operators required are one concave lens, one plano concave lens made of acrylic material, one ray box. We know that lens is a transparent medium bounded by two surfaces. See here, this is one surface. It is curved inward. So it is named as concave surface. And another surface is also curved inward. So it is also concave surface. So this lens has two concave surfaces. So it is named as biconcave lens or double concave lens, or simply we call it as concave lens. Now let us see what happens to light ray when the concave lens is placed in its path. These are the parallel rays. Now I am placing this concave lens in its path. See here. All the parallel rays incident on one of the refracting surface of this concave lens. After refraction, if we observe these rays, these refracted rays, all are spread in different directions. This is called diverging nature. So, concave lens, after refraction, all the rays are in divergent nature. That means concave lens belongs to diverging family. Now let us see what happens if I reverse this lens. See here. Now I am reversing this lens. Again, if you observe, after refraction, all the rays are spread in different directions. That is, the rays are divergent. And if we observe, the refracted rays are not meet at any point. But if we backtrack, these are all appears to be meet at some point on this principal axis. This point is called focus or principal focus of this concave lens. So concave lens forms virtual focus. Now I am going to explain this on board. See here. This is a one concave surface. This is another concave surface. This is concave lens or double concave lens. This is the optical center and this line is the principal axis. This is first refracting surface. This is second refracting surface. Here this lens is made of glass, so it is denser medium. It is placed in air, so it is surrounded by air is the medium, which is rarer medium here. Now if light is the ray is incident parallel on the one of the refracting surface of this concave lens. After refraction at the interface between air and glass, it bends. So the bending takes place with respect to normal at the surface. So I am extending this surface. See here, it is a part of a sphere. This is the center of the sphere. I am drawing the normal at this interface. The normal should be passed through the center of the sphere. Here light ray traveling from rarer to denser, it bends towards the normal. So it bends like this. Again at the second refracting surface, again refraction takes place. So I am extending this one. This is a sphere. This is the center of sphere. So this concave lens is the intersection of two spheres. Again I am drawing the normal. It should pass through the center of the sphere. At this second refracting surface, the light ray traveling from denser medium lens to rarer medium air. So when the light ray travels from denser medium to rarer medium, it bends away from the normal. This is the normal. This is the ray path. It spreads out, means it diverge. So I am extending this ray back. It appears to meet at some point on the principal axis. This is focus. But at school level, we are learning about thin lenses. Means whose thickness is very small compared to radii of curvature. So we are not considering the thickness of this lens. So net refraction takes place at one surface, that is shown like this. Thin concave lens is shown like this. This is the thin concave lens. This is the optical center. This is the principal axis. See here, if ray is parallel to principal axis, after refraction, it is divergent. So it goes like this. If we extend back, to meet some point on principal axis, this is focus. See here, I am drawing one more ray, which is parallel. It is divergent lens. It deviates. If I extend, it appears to meet at some point on principal axis. This is focus. See here, if I extend this one, this is one sphere. This is another sphere as centers. So from this, we understood that concave lens or double concave lens belongs to diverging family. Now let us see plano concave lens. See here, if we observe this lens, here one surface is plane, means curvature of this plane surface is 0, but the radius of curvature for this plane surface is infinite. Again, if we observe another surface, this is curved inward, means it is concave surface. So this lens has two surfaces, one is plane surface, another one is concave surface. It is named as plano concave lens. Now what happens to light ray when it is placed in its path? See here, this is the parallel rays. Now I am placing this plano concave lens in the path of light rays. See here, again you observe, when I am placing this plano concave lens in the path of the light rays, all the rays, parallel rays incident on the plane surface of the plano concave lens. If we observe the refracted rays, all are spread in different directions. So here plano concave lens also diverges the rays, means it is a divergent lens, it belongs to divergent family. Now see here, what happens if I change the lens, reverse the lens. Now I am reversing the lens. See here, now all the parallel rays are going to incident on the concave side of this plano concave lens. After refraction, again all are divergent. From this, we understood that plano concave lens is diverging lens. I am going to explain on board. See here, this is plane surface, this is concave. So it is named as plano concave lens. This is the optical center. Midpoint of the lens is named as optical center. It has two refracting surfaces. This is the first refracting surface. This is the second refracting surface. This lens is made of glass. Here it is denser medium. It is placed in air. So air is the rarer medium here. Now the ray is parallel to the principal axis, incident on the first refracting surface, that is plane. If the surface is plane, curvature is 0, but radius of curvature for this plane surface is infinite. Here it is traveling from rarer medium to denser medium, but it is a plane surface, so without deviation it goes like this, and refraction takes place at a second surface. Now I am extending this one. It is a sphere, So I am drawing the normal which passes through the center of this sphere. At second refracting surface, the light ray travels from denser medium to rarer medium, so it bends away from the normal. This is the normal, this is the actual path, so it deviates or spreads away from the normal, so it goes like this. If I extend, it meets at this point. This is the focus or principal focus. Now let us see, if I reverse this lens, what happens. This is plane surface, this is concave surface, this is the optical center, this is first refracting surface. Now the first refracting surface is concave, this is second refracting surface. Again, denser medium, here air, rarer medium, air, rarer medium, everything is same. Now see here, parallel ray incident on the first refracting surface, that is concave side of the plano-concave lens. So at here, I am drawing the sphere, the center, drawing the normal. So the light ray travels from rarer medium air to denser medium lens, it bends towards the normal like this. But at second refracting surface, it is the plane surface, so it goes like this. If I extend, it appears to be meet at some point on principal axis. This is focus. So, dear students, from this explanation and activity, we understood that concave lens and plano-concave lens both are divergent in nature. They belong to diverging family. Thank you.